We're on page 66, topic 13, and we're going to do 7 problems here, and the 7 problems we're going to do are 6H and 6J, first 2, and then from 7 we're going to do 7I and 7J, and finally from 8 we're going to do 3 problems. We're going to do 8B, 8H, and HN. So let's get started. And here 6H, we're asked to factor each difference of squares. We have 16x squared minus 121y squared. So we look at the 16, that's 4 squared. We look at the 121, it's 11 squared. So we can make the first term 4x because that'll give us the 16x squared. And then we can add 11y here, subtract 11y here, because 11 times 11 would give us 1 minus 121, plus 11y times minus 11y would give us minus 121y squared. So you can see whatever is in this bracket is identical to this bracket except for the difference in the sign. There's the inner and outer terms sum to 0. So we got plus 44xy as the inner and minus 44xy as the outer. They sum to 0. So there's only 2 terms, this term and this term. And that's characteristic of the difference in squares. Same here. So here we have x to the 4th minus 1, and what we ask ourselves is what times what gives us x to the 4th. It has to be x squared times x squared gives us x to the 4th, and plus 1 times minus 1 gives us minus 1. So this is the difference of squares. This term is identical to this term. This term is identical to that. The only thing difference here is that one is plus and one is minus. So what happens here is that the inner term plus x squared is canceled by the outer term minus x squared. So we only have 2 terms, the first times the first and the last times the last. Now what you have to be careful about here is that this is not factored. So a lot of people might stop the problem here and then the answer would be incomplete, because this again is the difference of squares. It's x plus 1 times x minus 1. The first times the first gives me x squared, and plus 1 times minus 1 gives me minus 1. The plus 1x inner is canceled by the minus 1x outer. So this is the final answer. And if you did this, if you left it here, it would be incomplete. So one of the things you should always be asking yourself when you finish a problem is, can I factor something more? If you finish the problem here, you have to say to yourself, oh, can this be factorable? This is not factorable. There's no way I can factor this. Because you say, well, why not x plus 1 squared? Because you're missing the term. You would need x squared plus 2x plus 1 to get this to be factorable. Number 7I, factor this difference of cubes. And the key part here is to realize, try to see a way that, ask yourself, okay, how can I turn this number into a perfect cube and this number into a perfect cube? So let's look at this. In this problem, you have to look for the cube roots of number. So the cube root of 8 is 2. This means that 2 multiplied by itself 3 times is 8. So you're looking for the cube root of 512, and you're looking for the cube root of 343. In other words, what number multiplied by itself 3 times gives you 512? What number multiplied by itself gives you 343? Well, let's just go over this. We know that 2 cubed is 8. 3 times 3 times 3 is 27. 4 times 4 times 4, which is 4 cubed, gives you 64. 5 times 5 is 25, and 25 times 5 is 125, so 5 cubed is this. 6 cubed is 216. 7 cubed is 343, right there. And 8 cubed, 8 multiplied by itself, is 512. So instead of writing this problem as 512, x cubed minus 343, we could write it as 8 cubed, because 8 cubed is 512. And instead of 343, we could write 7 cubed. Now we have, we're going to take this term here, put it here, take the x, put it here, minus 7, put it here. This squared gives me this. We multiply minus 7 times 8x. We get minus 56x, and change the sign. We get plus 56x. And minus 7 squared gives us plus 49. So if I were to multiply 8x times each one of these terms in the bracket, and then multiply minus 7 times each of these 3 terms in the bracket, and sum it, take all the terms, collect like terms, I would be left with this. Here, first thing we have to do is look for a greatest common factor. So there is, if you take 125 here, 125 will go into 125, and it happens to go into 1,008 times. So the first thing we're going to do is factor out 125 as the greatest common factor. 125 times x cubed gives me this. 125 times plus 8 gives me plus 1,000. Now, this we can leave as this, and 8 is 2 cubed. So we have 125, we put the x here, we put the 2 here, we square the first term, we get x squared. We multiply plus 2 times x, we get plus 2x, and change its sign, minus 2x. And plus 2 times plus 2 gives us plus 4. So this is the complete factor. Go back and review your sum or difference in cubes if you're not certain of this. Now, here we are asked to factor completely 50x cubed minus 100x squared minus 10x squared plus 20x. And the first thing we look for is the greatest common factor. So we ask ourselves, what's the highest number that goes into 50, 100, 10, and 20? And the highest number that goes into that is 10. So that's our first factor. And we look for the lowest value of x squared, which is this one here, x to the 1. So 10 times x gives us 10x's, which is the greatest common factor. We take the original problem, which is this over here. We take out the 10x, which is the common factor to each one of these terms. The lowest number is 10, and the lowest power of x is x to the 1, so we take that out. So 10x times 5x squared gives me 50x cubed. 10x times minus 10x gives me minus 100x squared. 10x times minus x gives me minus 10x squared. And 10x times plus 2 gives me plus 20x. Now what I'm going to do is I'm going to group by factor here. So I'm going to say, okay, what can I take out of these two terms? What's common to it? And it's 5x. So 5x times x minus 2, 5x times x gives me 5x squared. 5x times minus 2 gives me minus 10x. And then I'm left with minus bracket x plus 2, or I have to change this to a minus, and to make it plus, because the minus times the minus gives me the plus. And there's an implied 1 here, so I've just put that in for convenience sake to make it a little easier to understand. Now, out of these, I'm going to factor x minus 2. It's common to this term and this term, and then I'm going to be left with 5x minus 1. So factor out x minus 2 because it's common to both these terms, and then I'm left with 5x here and minus 1 here. So these are the factors. Now I'm just going to remove these outer set of brackets here because I really don't need them. I don't need this and I don't need that. So I get this. I got the 10x, x minus 2, 5x minus 1. Now I'm just going to go into a little different procedure for how you would go from this to this. So what I've done is I've established that the greatest common factor is 10x. What I can do is take this term, divide it by the 10x, take this term, divide it by the 10x, take this term, divide it by the 10x, and take the last term and divide it by the 10x. And that's what I've done here. So 50x cubed divided by 10x gives me plus 5x squared. 10 goes into 50, and I say 3 minus 1 gives me x squared, so I get plus 5x squared, which is this term here. I take the next term, minus 100x squared, and I divide that also by the 10x, the greatest common factor. The 10 goes into 100 minus 10 times. X squared divided by x gives me x, so that gives me this term here. Then I take the third term, minus 10x squared, and which is, let me just see, right here, minus 10x squared divided by 10x, so this one, minus 10x squared divided by 10x, and the 10's cancel, and I just have minus x, so that becomes this term right here. And then I take the last term right over here, 20x, and divide it by the 10x, and I get plus 2, so that goes over here. That's just an alternate way of going from here to here. So what I've done is look for the greatest common factor, and then I've taken each term in the top line right here and divided it by the greatest common factor. And 5x squared minus 10x minus x plus 2. So if you look, 5x squared minus 10x minus x plus 2. That's all these terms here. Just a different way of doing it. If you're perfectly comfortable doing this sort of in your head here, it's okay. But if you want a more systematic way of doing it, that's how you do it. So here we have 16 ax cubed and 54 ay cubed. We look for the greatest common factor always, and we could remove the number 2. 2 goes into 16 and 2 goes into 54. You can say, well, why not use 8? 8 goes into 16, but 8 doesn't go into 54. So you have to choose a number that the highest number that'll go into both these numbers, it's 2. And then a is common to both. We put 2a in. Now 2a times 8x cubed gives me 16ax cubed. 2a times 27y cubed gives me 54ay cubed. So now the key thing is to realize that 8 is 2 cubed. This is x cubed. 27 is 3 cubed. And now we've got the sum of cubes here, and we factor that. The 2a is just the 2a. Now here's what we've got to factor. So the 2 here becomes the 2 here. The x becomes the x plus 3y. Square this, I get 4x squared. multiply these two, 2y times 3y times 2x is 6xy, and change the sign. I get minus 6xy, and plus 3y squared gives me plus 9y squared. And that's our complete factoring of this one. So the last problem we're going to do here is to factor out. In this case, you can see that you could factor out x minus 2 because it's common to both. X minus 2 is in this term, and x minus 2 is in that one. So if you factor this, you can rewrite this as x squared x minus 2. There's an implied 1 here, so you could just put a 1 here. Makes it a little easier. X minus 2. Now factor out the x minus 2, and you're left with x squared minus 1, which can be factored as x plus 1, x minus 1, this part here. So if you stop the problem here, you wouldn't have been completely factored. So let's go over this again. We're going to put a 1 here to start with. Makes it a little easier. Factor out the x minus 2 because it's common to both terms. We're left with x squared right here, the minus 1 right here. Now we factor this as x plus 1, x minus 1. Of course, this stays the same down here. So this completes page 66.